Hello, and welcome to the research and broadcast vessel Aldebaran. We are here at the moment at the shipyard in Constance. We wanted to go out today, and we have been out today, but then we get a storm warning from the official weather forecast. So we had go immediately back to the port, and it was really a bit stormy here inside. For example, some containers were blown into the water. My name is Frank. I'm the captain of the boat, and I really welcome you to this live interactive research experience now. And before we start the experiences, I want to introduce the team. So first of all, we have our marine biologist. This is Valeska.
Hey
And
everyone.
then we have Catherine, who is having the camera, and this is Catherine now. And then we go down to the saloon of the boat, and here you can see our production suite, which is operated by Marie. This is a really brand new editing machine, and she could combine 10 cameras at the same time. And we are in the stage of improvising a bit because all this technology is brand new and never happened from this boat. So this is the production area. Then we have kind of scientific area, which is in the next video, in the next picture. Yeah, this is the area of the scientists where we do the microscope imaging later. And then I want to introduce you to the area of the navigator. So we have a lot of YHF and all stuff of radio equipment here. We have, for example, also a satellite radio. We have handy talkies, which is necessary if we have interactions between the skipper and the scientist, and for sure also if we have a case of emergency, we have to call the police, we have to call the rescue institutions. So here we have a sea map. This is a digital sea map. It's like on a professional boat, not designed for a yacht. And here we can see the Lake Constance. We can see the port where we are at the moment. And on the red line, we can see where we have been today to take some samples until the storm came up. So this is now the Lake Constance. In total, we can see it more easily on the right map here. Just a second. So here is Friedrichshafen, here is Konstanz, the red thing is our boat. And we are working now here in the so-called Konstanzer Trichter. It's better seen here on the left-hand sea map. Here the red lines are the ones we went today to take some samples. We will explain you later. So yeah, and a lot of telephones, and here is all the electricity. We have a lot of fuses. We have a lot of batteries in the boat. So at the moment we get some electricity from the land, but normally we use the electricity from the batteries to survive 1 to 2 days with this mass of technology. Yeah, the specialty of the boat is not only that it's a combination of research and communication, like you can see now. This boat is made of aluminium. It's really robust. And we have a rectable keel. So normally you have a draft of, let's say, 2 meter 50. But when you look to the deep, we have 2 meter and 10. So with a boat of this size, you normally can't go to this area, but we can lift up the keel and we can lift up also the rudder. So we are able to navigate in 80 centimeter deep. Yeah, then let's look a little bit to the schedule of the program today. And Marie will show us now the the information what we like to do now. Just a second. Yeah, here again the map of Lake Constance, and on the second map I show you. No, no, show now. You can see the different depths of the Lake Constance. So the deep blue colors are the big deeps of approximately 200 to 250 meters. And today we have been on depths of around 50 meters. And this is the weather situation today. So you can see on 1400 hours we have a lot of wind coming up, and it was really true. And it started to rain. At the moment we don't have rain. So we are happy that we can do all the experiments without rain. And now I will explain a bit about the program we have prepared for you. First of all, we show you some instruments which are normally used for looking how deep you can see in the lake. We are looking for plankton, and we are looking for temperature. And all this stuff is done by Valeska. And after that, we go to the shallow water area, like here in the harbor. And in the shallow water area, you have the big chance to see how our underwater drone is working. We are talking a bit about biodiversity, and we will look into the microscope. And now I want to hand over to my colleague Valeska, and she will start the scientific program now.
Yeah, thank you. So, hey everyone, also from my side, welcome to the Aldebaran. My name's Valeska, I'm 27 and I'm just like a freshly graduated marine biologist. So I studied at Bremen University, that's in Bremen, so that's close to the North Sea. And as I'm a marine biologist, I'm more specialized on marine systems, on saltwater systems. Lake Constance now is a freshwater system, it's a lake, but nevertheless it's just as exciting and as interesting, and I'm like happy to take you on a scientific mini expedition today. So we have to improvise a bit now because we cannot go out and we cannot really see the deep water experiments like 100%, but we'll still do it so that you all get an idea of how it works. And then the shallow water depth experiments we can do perfectly here. As Frank just said, it's like 2.5 meters depth around here. So lakes are very special systems, let's say, because they're enclosed, so they're closed systems. The only entrance and outgo here are rivers. It's not like an ocean. So there's less external input, let's say. And all the kind of ecological processes are working different. So it's a very special ecosystem. And very important to understand lakes are different zones that we have in the lake. And the first is like a vertical zonation that has to do with light. And to start on this, we'll go into a super short presentation, and I'll just run you through like a quick basics on the slide. To introduce to you the first experiment that is about light and visibility depth of a lake. So let's see, just see at the slides. Okay, so Lake Constance is quite special because it's such a big lake, so that's something very rare actually to have a lake that is that big and that deep. As you can see here, maximum depth of Lake Constance is actually over 250 meters, which is, it's really like insane. So in northern Germany we have nothing like this. So yeah, it's a massive water volume that this lake holds. And yeah, so, but if you look at the surface, it's kind of empty, I'd say. So you just see like a very large empty space, and I often just look at it and then I look through the water and there's like nothing really. I'm just wondering what is living there, and the all the fish that we know are living there, what are they actually feeding on? Because there are no plants, there's no grassland, there's no forest that we know from land where you have cows or horses or whatever grazing on grass. Something like this is not really existing in that way in a lake. So no grass land in a lake. But what we do have and what is existing like in the whole lake, but we cannot really see with our with our eyes, is the microscopic algae that we call phytoplankton, which is the equivalent to grass on land basically, because everything is feeding on them. So they're like the really basis of all food chains in aquatic systems, so ocean as well as lakes and rivers. So these microscopic algae are in a way like plants, a bit different, but the basic principle, how they generate energy and they're growing and reproducing and stuff, is based on the same mechanism. And that is that plants and algae, they need water, they need nutrients, CO2 and sunlight to produce oxygen for us to breathe, you all know that, and glucose, so sugar, so the real kind of energy outcome of that process. And I hope you know that, and I'm sure you had that in biology at some point. This process is called photosynthesis. So this is how plants on land are generating energy, and this is also the same process that the phytoplankton, so the small algae in a lake, are working with. So I think it's quite obvious that in a lake, water is not the limited thing, right? So water is all around them, and the water holds nutrients, and the water holds CO2. So one very important factor that is like super important for their growth then is obviously light, so sunlight. And the first question that arises kind of, okay, is the light the same in the whole system? So do we have light in every part of the lake, or is it like going really down to 250 meters depth? And a very simple but brilliant way to measure that was invented in 1865 by a guy called Angelo Secchi. And he invented a tool to measure visibility depth with what we call Secchi disk. So it's really named after him. And this very simple thing that we'll use in a second to see how we measure visibility depth, is used today exactly the same as it was used back then. So we actually have a tool to measure a parameter exactly the same way for 155 years now, which is very, very cool, because all the like super high-tech things that we invent today are great to measure things, but you don't really have very long-term data sets because they were not existing in 1850, right? So this is actually a really cool thing, and we will just take a look at it, how it works today. And I just need a second to prepare, and so I'm just handing back to Frank for a second, and then I'll see you soon on the diving deck.
Yeah, welcome back on the deck here of Aldebaran. While Valeska is preparing the Secchi disc, I will a bit more explain about the boat. So the boat is operating since 30 years, nearly 30 years, as a research and broadcast vessel. It was rebuilt here in Baden-Württemberg to a kind of multimedia platform many years ago. And this boat already sailed to different places, like in the ocean, the North Sea, the Baltic Sea. We have been in the Mediterranean. We have been a lot of excursions and expeditions to Canary Islands. For example, we made research for whales and dolphins on the south of Tenerife in Canary Islands. And our data will provide the authorities to make a natural sanctuary, which it exists today. And we also have been in the Caribbean, for example, in Belize, in Central America, on the footsteps of climate change, to show how islands will disappear and to show how, for example, the coral reef system will suffer from climate change. Yeah, now I hand over to my colleague Valeska, and she will show you how we can measure normally the deep and the visibility in a lake.
Okay, so like you already saw on my slide, so this is all it. So this is the Seki disc. This is what it takes to build this thing. So it's just a rope, and then the Seki disc itself is just a disc made of white plastic, so that the light gets reflected on the surface of the white plastic, and then we can see it when we just let it down into the water. And then down here we just have a weight to make sure that the whole thing is really sinking. And this is it. So this is all the magic. So before we let it down in the water to measure depth, one very important thing if you work on ships is that everything that is used, especially scientific equipment, which sometimes is super expensive, needs to be tied to the boat. So you always have to know and do your knots, because like nothing is more annoying than losing your scientific equipment because you're just like distracted, or you're so focused on your work that you just hand out the rope and you hand it out, and then it's gone. And here it's okay because it's so shallow that I could pick it up again. But imagine that we would be like out and over the deepest point of 250 meter. If it's gone, then it's gone. So always do your knots. And then the only thing to measure visibility depth now with the Seki disc is to put it into the water, lower it down, and then watch closely when the white disc disappears. So we do that now. We will here not be able to let it down until we're not like seeing it, because the water here is too clear and too shallow. But this is just so that you get an idea how it works. So just lower it down into the water, and then that's like on the bottom now, and you can still see it. So the visibility depth is definitely more than 2.5 meters. But if we would let it down more and more now, it would disappear in darkness at some point. And we did that with like the other kids from 5th grade this morning, and we found out that our disc disappeared at around 7.5 meters depth. So this is the visibility depth. And one important thing to note here is that algae just need very, very few light to do photosynthesis. So they actually only need 1% of the sunlight to be able to generate energy and grow by photosynthesis. So the euphotic zone, as we call it, so the zone where light can penetrate into the water and algae can grow, is called euphotic zone. And this is actually 2.5 times the visibility depth. And this is because if we watch the disk disappear, the sun goes through the disk to our eyes. So it's kind of more way than it just goes when it just goes straight down. So this is a formula that has been like found out years ago and is used to calculate euphotic zones. So it's visibility depth times 2.5, which means that if we measure 7 meters, let's say, out today, so it's 7 meters multiplied by 2.5. So let's say we have around 60 meters of euphotic zone at the moment, which is crazy. So that's very, very deep. But you can also kind of already see that if you look into the water, because Lake Constance right now is crystal clear, so it's a great visibility. So the light can really penetrate quite deep. And this also means that the algae can grow up to a depth of this like 16 meters, let's say, which is quite a lot. And this is the first important zonation that we have in a lake. So we have one zone at the top that is penetrated by light, and algae can do photosynthesis, which also means that they can produce oxygen in that zone. And the other zone that lies below that light zone, below the euphotic zone, that is the dark zone where light cannot penetrate through, where algae cannot grow, and where algae cannot produce oxygen for like all the other species that are living in a lake. So this is the very first important zonation in the lake that you have to remember, right? So before I prepare the next one, I'll just hand over to do a few things, and then we will look at the next experiment.
Yeah, Frank again. And while Valeska is looking for the next scientific equipment, I like to share some ideas of the boat. So this is the steering wheel, and here we have some instruments where the navigator can see how deep we are, where the wind is coming from, and for sure we have a compass to see the direction, and we also have kind of autopilot to steer the boat, because if we have heavy rain or if we go a long time in the same distance, it's easier to use the autopilot than to steer manually. And then we have a lot of things for diving. We have a dive compressor on the boat, and we have also a lot of things for communication. So this is the working space for the scientists, but on top of this place, we have a lot of antennas. We have antennas for the communication, for the radio. The two small antennas we added new. These are the antennas which transmit the streams, the online streams, to your classroom. And we have some more for and we have a really precise navigator, which is on the left side, receiving 7 to 10 satellites at the same moment with a lot of antennas, so we can navigate with this kind of compass very precisely, and we can find the dive spaces we have been working again years after. Yeah, so I hope this is fine. If you have any questions on the boat, feel free to write it in the chat, and we will answer this after the next experiment with Valeska. She's preparing the plankton net.
Yeah, so I got our next scientific tool set up and ready to go. So as I just said, the important thing to remember from the first experiment is that we have a zone in the lake that is light, where algae are living, where algae are producing oxygen, and then a zone below that where this is not the case, where light is not penetrating through, the algae are not growing and not producing oxygen. So in this euphotic zone where it's light and where algae, we also find all the small little creatures that are feeding on algae, which are called zooplankton. So remember, algae are called phytoplankton, and the small crustaceans and the small fish larvae that are teeny tiny, really, are called zooplankton. And if we want to take a closer look at plankton, we have to fish for that, because it's just too small. We cannot go with the magnification glass into the water and try looking for them. We need to fish them, and then we need to look at them under a microscope, because they're so small. And as they are so small, we need a special device to fish for them, and this is called a plankton net. This is a very small one, but it's enough to filter some animals and algae for us to look at. So this is a very, very thin textile here where really only water is passing through, and all the phyto and zooplankton is caught and then washed into this little cylinder down here, where we can then leave them out through this. So this is closed, and we want that closed if we now put the net into the water, because if it is open, the plankton just gets washed through, and we don't want that, because we want to look at it under the microscope a bit later. So the only thing that we have to do now with the plankton net, after we made our knot, right, remember? We just lower it down into the water again, just like the sake disc. Just let it sink down. And then you just you can use a rope to just let it sink as deep as you want. So it doesn't matter if we take samples now from just a shallow depth like here, or you have a rope of 100 meters and then filter plankton from 100 meters. That also works. So now we just tuck it in quite quickly because we want the plankton to be washed in it. And then if we're up, we just do like this to get everything that is stuck on top washed down as well. And then this is basically it. So we should now have our tiny organisms down here. So I just have to go because Frank left me. What an assistant. Here for a glass. Let's see, I have one here. And then we can just let everything in here. So just open up, swoop, there we go. And then we can use a splash bottle like this to just go over it once again to make sure that we really get everything that we caught and everything that we filtered in here. Okay, as we only had a depth of, like I said, 2.5 meters, we will not have super much plankton in here because we couldn't filter that much. But when we did that earlier today, the whole water was really, we did it on 20 meters, was really alive, so you could really see the small crustaceans jumping around, but I can also see some moving around here, so we definitely caught some plankton. You can try to see it through the camera. If you cannot see it, then you just have to believe me here that things are actually moving in there. But when we take a sample later to look at it under the microscope, you'll see how much is alive in there. So we'll just give them some more water, because if you let them dry, they're gonna die. I mean, they're living in water. And then close it. And now, if you take living samples like this, so all those small creatures in there, you always have to make sure, if you want to keep them alive, which you should do, that you don't let them out in the sun so that they kind of get super hot in here and then die. And as Lake Constance is still quite cold, I will put them into the fridge until we look at them later to just make them cool and comfy, let's say. So I just hand that down. And yeah, let's see what we caught a bit later. So that was the plankton net. And
yeah, I think we also want to look for the picture of the lake. And for this, we have also different sampling methods. So we can use a probe, an electronic probe, but we want to share with you how this measurement is doing manually. And so Valeska is preparing the next experiment, which is the so-called Niskin bottle. And she will look for the temperature, and then we will look for the data we took before here on the lake on different depths. And yeah, so I hand on again to Valeska.
yes, so that's great scientific equipment, right? So that's just a ball to collect some water, and then we have here a digital thermometer, because normally when you look at water temperatures, because maybe you want to know if it's safe to go swimming already, so you just check on the internet, okay, what is the water temperature now? Am I freezing my whatever off, or is it all good? Then you find data of the water temperature that is taken at the surface. So they go out to the middle of the lake, and then they measure the water temperature at around 30 centimeters depth. And this is then what you find on the internet. Because, I mean, this is kind of like the depth you're swimming at, right? So this is the one that is interesting for you. So we can do that straight away. So I will just use that ball, get some water, and then measure temperature so that you can see what the actual water surface temperature looks like at the moment. Okay, just put that one on. Just place it here. Okay, just put it in. And then let's see what it says. Turning it on would be good. Okay. All right, it's actually cooled down a bit again because like when we measured it earlier today with the others, we had a temperature of 15.8. Are we still here? Talk to me. We're just having some technical issues here. Stay. We can also, like, because we have some issues with the camera, so I just tell you and you have to believe me. So the thermometer is showing me 14.3 degrees at the moment, which, like I said, is already a bit cooler than this morning, which is probably due to the rain. Because that, believe me, is quite cold on my skin right now. So normally, and I will show you that as soon as the camera is working again, we can use now another scientific advice to measure temperature at depth, because as you probably already kind of imagined, in a lake that is as deep as Lake Constance, 250 meters, the water temperature will most likely be not the same on the surface as in 250 meters depth, right? Because as we just learned, the sun is penetrating through the first, here, let's say, 15 meters, and below it's dark. And we all know, you know, if like the sun is not shining, or at night, it's cooler because we don't get the energy from the sun. So the water temperature will most likely be cooler down there. And now you, of course, can just use a thermometer like I used with you a second ago, just with a like super, super long cable, and you lower it down and then measure temperature at depth. That's possible, but there are also different scientific like devices that you can use, and we will show you one a bit later. So if we look at the water temperature that we found out earlier today when we were at the deep water zone, we have here like the first data point on the graph. You can see that. So you see on the x-axis you see temperature from 0 to 28 degrees, and then on the y-axis you see the depth from 0 to 200 meters. And if you look at the first blue thingy that you can see on the graph, so this is the temperature that we measured earlier on the surface, so it was around 16 degrees. And if we now continue and take more data points while going down, we can see that in the first 15 meters, we have around the same temperature, so it's not really getting any colder, it's around 16 degrees. But then very suddenly, below 15 meters, we get that like cooling effect. So it's getting cooler, and we see that at a depth of around 60 meters, we only have a temperature of around 6 degrees. So that's kind of a drop of 10 degrees. So we don't only see this zonation by like using the Secchi disk and measuring the euphotic zone and the light, but we can also actually see it when we measure temperature, right? So we found out that the euphotic zone is 15 meters, and now we see on this graph that also the temperature is making a jump at 15 meters. And one very interesting thing now is that this varies a lot with seasons. So in winter, where like sun is not like having the same power as in summer, you all know that, we're all walking around in shorts and tops in summer, and all walking around in thick clothes in winter, and the water and the creatures in the water experiencing like exactly the same. There's no so much like sun power. and there might be even ice on the surface and stuff, so it's freezing cold. And we have the same temperature here of around 6 to 4 degrees Celsius from the surface to 250 meters depth. So it's not really changing. We don't see that gap that we see in summer. Because in orange you see the summer curve again, a bit bigger with that very, very high temperature. So Lake Constance in summer actually gets around 25 degrees surface temperature. So very, very nice for swimming. And then you see that gap, that like jump from that high temperature down to 6 degrees at depth. And this first layer, so the surface layer where it's warm and cozy in summer, then just jump thing, we call epilimnion. So this is the surface layer, the light layer, the warm layer. And then we have that deep layer where temperature, no matter really if it's summer or winter, is always between 6 and 4 degrees and dark. So not very nice down there. And then we have the thermocline, this layer of water where the temperature suddenly jumps from warm to cold. And yeah, so this is a very important layer. And you can actually see that really underwater. So when you're diving, you can actually see this thermocline because in the like surface layer where all the algae are growing and where all the zooplankton is grazing on the phytoplankton, it's very, very blurry. So you see that here, that's this like white fog in the water. And then suddenly you see that very sharp gap, that like layer, and underneath it suddenly it's clear. And I'm also a diver. I don't know if like you guys, some of you have been diving before, and especially in lakes, you can really feel that. So in your wetsuit, when you're dropping below thermocline, you really get that 10 degrees jump in temperature, and it's really like a ooh every time you kind of leave that area. So you can not only see that, but also feel it. Important in graphs like this, so just let's look at it once again, is that we always, in marine and aquatic science, when we do graphs, have depth at the y-axis. That is very important because that's just a natural thing, right? Because like a lake and water, it's going down. That's just it's going, from our point of view, it's going down. And this is why we always have temperature, have depth here on the y-axis and temperature on the x-axis. So that might be a bit different than you normally learn it, but here that's just one important thing to note. And this is why you also get that very nice temperature profile. So I think I can just like leave the presentation here for a second before we do the next experiment, and just hand over back to Dick.
Yeah, welcome again here on the boat. And I want to show you a bit about the function and all the things we have to do. So normally, if we do all things from internet, from driving the boat, from diving to scientific things and the cook, we prepared a small film to explain you how many functions on board we will need. But unfortunately, this boat has a maximum capacity of 12 people. So we have to share all those functions among the 12 people. And when you like to work, for example, voluntarily here on board of Aldebaran, you have to bring with you different skills. And I will show you now a small video about all the skills and all the function on board. Let's see. Yeah, so this is the boat, and running in Belize in Central America. And this guy is the skipper. He has all the responsibility for everything on the boat, and he has to navigate, he has to make all the calculations, he has to make all the details of the customs and authorities, and it's a hard job. This is the navigation area we showed before, and this is directed here. This is the reason we can navigate in really shallow waters, for example, this reef system in Central America. And the second guy leading the boat is the co-skipper, and he has for sure helping hands on the boat. They do more or less everything, so everybody has to be a helping hand. Then we have the diving area. We have one diver who is the responsible one. This could be the skipper as well. And we are diving from the platform on the back of the boat. We are using the modernst underwater cameras. And when we do shootings underwater, like we sometimes do here in Lake Constance as well, the diver, the cameraman needs an assistant who will look for the diver. For example, when I dive there, it happened that a shark would like to attack me, and so it prevented me from this shark. Then we have scientists on the boat, 2 to 3 scientists, and here scientists from a museum in Berlin. This scientist is from Hamburg, looking for climate change. And then we have the production personnel on the boat. This is, for example, moderator from the ZDF, which is the National German TV. They reported for 1 week about climate change in Greece from this Aldebaran. And then we have the video technique, which is done by Marie at the
Wir sind
moment.
mit 3 Kameras hier
And she is
unterwegs
mixing
und
all the
zeichnen die
programs
ganze Zeit auf HD
from
auf.
the boat.
Das heißt, wir haben unheimliche Datenmengen, die abends noch
these are
eingeladen werden
at
müssen.
least
Und jetzt bin ich
17
gerade dabei,
functions
einfach mal
on
zu
a
gucken,
really
wie sind die
small
Farben,
boat.
haben wir richtig belichtet,
And,
ist das Material generell in Ordnung.
demanding
So
and
could you
exciting at the
just
same
explain to me
time.
what you're doing?
And we have someone who has
Yes, this is a
the
transplant
editor
project with the
on
Acropora
the
palmata. It's
editor-in-chief on the
commonly
boat.
known as
He
elkhorn
has to
coral.
organize all the interviews and bring all things together that we could make also real documentaries from this boat. And sometimes we take the challenge and sit on the mast, for example, to make this shooting. And this is me holding the microphone, so we also need someone who is doing the technique for the audio systems. Yeah, then we have to have a camera assistant. And we have, last but least, someone who has to repair all the stuff who got damaged on the boat because salt water and electricity is really demanding, and a lot of things crash during the day. So, for example, today we had a crash with a camera, but I think we will fix it. And last but not least, all the things are working only when the food is good. Yeah, these are 19 jobs done by normally 8 crew members. And yeah, then let's continue with the next experiment with Valeska. She is preparing now the samples, I think, for the microscope.
Ich kann auch den Rhythmus schöpfen. Ich bin schon drin. Okay. Okay, so we just have some technical problems right now with the camera. This is why I look like a bit less good than before, let's say it that way. So, but I'm still think we can continue. So to kind of yeah, we just use a drone now, I think. So we just use a drone to see how the underwater world looks like, because in some regions, some cases it's very difficult to send divers in. Sometimes you might also don't have any on board, and then you can use now underwater drones to just fly through basically the water and see what is down there, and also if it might be worth it to send divers down, because just a technical thing. So we just I hope that we don't have any technical issues with this one now, because sometimes it's a bit intense. But the way the way it functions is that, so you have a fish finder and a camera here and a camera there, and then this is kind of the picture that we're gonna see, and then we have different rotors that is keeping the drone moving back and forth. So back here back and forth, and also up here and down here for like moving up and down in the water column. So just have to tie like all the cables very close, because water and electricity is something that doesn't go very well together. So you also have to be very careful with that. So I would just put it in now, and you will immediately see, even like it's actually quite heavy, but when you put it into the water, it actually already floats. So it's not just sinking down and you lose it, but it's actually, yeah, floating on the surface. So let's see if it is alive. Yeah, here we go. So it's talking to us, and then you have this like gamepad. All of you that are playing like with PlayStation stuff, you know that. So just going forward a bit, and this one is connected to a cable, so it's not the one that you're flying up in the air. You always have to like use that cable. So it can go down now, going down, and then just see, like, go to the camera of the drone and see how the underwater world here looks like in Lake Constance. Okay, I just have to go to the screen now to see what you see. Yeah. So in harbors, normally you don't have very exciting like flora and fauna, because so many ships are going in, and the distractions to the lake, the bottom of the lake, and all the plants that would normally be growing are too heavy. So in harbors, you normally don't find like very nice underwater forests and very nice macrophytes as you would find like in other bays. So what we will do now is that we will show you a video that the drone recorded in a very nice bay here, not very far from our position, but outside of an harbor, so with very nice macrophytes, very nice plants, and we just see how it looks there. Okay, so you already see it's much greener than the picture that we just had from the harbor. So you can see here the underwater forest of actually algae. So this small green plants that you can see, that's called stoneworts, and they're not higher plants. Oh, that was a stickleback. Here it comes again, a small one, but they're actually algae. Stickleback again. Hey, buddy. Nice. And the bigger plants that you can see that are like having this proper green leaves are called pond weeds. And we have different ones here at Lake Constance. So there are like ones with bigger leaves, ones with smaller leaves, ones that are growing like very high up in the water column, and some that stay quite small. And this like small grassland, so these like algae that I just told you about, the stoneworts, they're actually, oops, okay, that was like, let's find our way up again, here we are. So these are actually like an indicator for very, very good water quality. So they're growing in waters that are very clear, very healthy, let's say. So if you find stoneworts underwater, you know that the water quality is very good. They're quite special plants, so they have an extremely high photosynthetic rate. So let's say they're doing photosynthesis like crazy, which results in the fact that they have calcium carbonate that kind of is like pouring out of their leaves and gives them a very strange, for plant, very strange texture. So they're very, I don't know how to say that. I would love to just like give you some into your hands so that you can feel it yourself, but they're very, not very flexible and not really feeling like plants, and that's because of the calcium carbonate in their leaves. So that we can find them here in the base of Lake Constance is, like I said, a very good sign. And also the pond weeds that we saw, so the bigger plants with like the bigger leaves are also just growing in lakes that are quite healthy. So you can see by looking at, you can also see by like looking at macrophytes, so looking at plants in a lake. You don't have to measure water parameters necessarily, so you don't have to measure nutrients or pH or like heavy metals. By looking at the communities of plants in a lake, you can already find out and make a like hypothesis if the water quality is good or bad, because some plants are just growing in waters that are very clear and healthy, and some prefer or some, let's say not prefer, but some are able to withstand very poor water qualities. And if you find like these plants where you know they can withstand like very high temperatures, very bad pH, very like super high level of nutrients, then you already know that you have a lake where the water quality is actually quite poor. So yeah, that's a very nice thing to do, like just looking at ecosystem communities like these plants, and then kind of make an assumption about the water quality. So, and I'll just take a quick look on deck if the camera's, yay, it's working again. So I'm just making my way up now.
So we
Warte.
because the drone is underwater, and a bird is swimming around the and the bird is swimming around the drone and looking if it's something to eat or not. But the blue lights of the drone are flashing, so the bird doesn't know if the drone is a fish or not. And for sure, it's much too big for the bird. So Valeska is now bringing the drone back, and I think the next step will be that we looking for the small species in the microscope. We made some Sandra is Valeska is wet, yeah. So we make some samples with the Plankton net, and first we take out the drone, and after that we will go down again and look for the microscope. Yeah, then we have a lot of underwater cameras here on the boat. The drone is only one example. We have another very high resolution camera, which is here. This camera is normally used in professional environments like drilling platforms and for scientific use on very, very deep areas. And yeah, then on the boat, what I want to explain more are a lot of security systems. So in the last 30 years, nothing happened really with the boat. Once we lost the mast in a storm in the Biscaya, but everything of the rest went fine. So we have small life rafts like this. We have kind of a big life raft which is in a container on the front of the boat. It could be blown up with CO2, and then 12 people can sit in this life raft and stay for long times. I think the maximum was more than 1 or 2 months that people stay and keep safe in a life raft like this on the open ocean. Yeah, I think we're going now to the next experiment. We are looking for the bottom here below us, and we have a special bottom sampler, and Valeska will now explain the next experiment. She got a bit wet from the drone.
I got a bit wet from the drone. It didn't want to go out of the water, which I completely understand, so that's all good. So another thing that I wanted to show you, we have also again to improvise a bit, and luckily we took some samples earlier today that I can show you, because so what we normally do if we want to look at the benthic community, so organisms living on the bottom or in the bottom of a lake in the first like bit where oxygen can still penetrate in. We use sediment samplers, and the sediment sampler that we're using, that's quite heavy, is this. Fun thing was the guy who invented it, and it is just like a big like thingy that traps sediment when we let it down, and then we can look at the benthic community. So we're just gonna do that now so that you see how it works, and then we'll add so I will show you the samples and add that we like took earlier today, so that you see the species that I want you to see, which we will probably again, like the plants, will not find here in the harbor because, like I just said, the destructions by ships and traffic and just anchoring and stuff is too tough for the most plants and animals, so they prefer to have it like a bit more chilled, not so much traffic. So this one is already, you can see that, I didn't forget, it's already tied to the boat. We don't have to do that. And the way that it's functioning is super easy. So I just put that little thing in, and it just stays open like this. But if I let loose, and if the tension loses, it just snaps and traps the sediment. So the only thing that we basically have to do now is to let it fall very, very quickly to make sure that the tension is there all the time. We do that. Whoop. Just see if it worked. Fingers crossed. That's always kind of a bit of excitement in there if you do aquatic science, because you always let it disappear below the surface and you never know what you're bringing up. But that's also a nice thing. Here we go. At least it's closed. That's a good sign. So I'll just move it over here. And it's just water. So it didn't work. But that's also science. That's also fine. I would do it again now if I would know that there would be something super interesting for you to see. But as I already have the things that are interesting to see in my tube, I'm just gonna do this. And again, I know that I'm asking like a lot of trust from you, but just believe me, I got it up earlier today. So here is what you get when you like bottom sample the benthic communities of Lake Constance. And you might now think, ooh, there's quite something alive, so that's actually quite cool. I unfortunately have to tell you that it's not, because the only thing that we see are basically 3 species, and they're all not native to Lake Constance, which means that they're species that were carried into the lake. That like happens by ships that are, I don't know, first like cruising into the Mediterranean, and then they're sailing here, or they're transported via truck or whatever. Or people that have been on holidays and there are things stuck like below their shoes or on their like suitcases and stuff, and they bring tiny larvae, tiny mussels, tiny whatever with them. So this is like how species are carried into systems where they actually don't belong. And this here is the quagga mussel, die Quagga-Muschel, which is an invasive species. So this is what we call species that are not native to a system and then take over the whole community. So they're not only new to the system, but they're invasive because they wipe out like all the local inhabitants of the system that was there before. And in these fields of quagga mussels, we have another invasive guy here. That's a teeny tiny shrimp. That's called the tiger shrimp or the killer shrimp, because it's so successful in taking over the lake that it has killed a lot of like other like shrimp, a lot of other crustacean species. Why it's called tiger, I think you can see that it has like the stripes on its back, and they are specifically like they love the quagga fields. So the quagga mussels really like living all over the lake, and normally mussels need a hard substrate, so stone or like walls to grow on. But the quagga mussel actually can grow on everything, so they're also growing on the leaves of plants and just taking over the whole space. And they're so successful that if you, like we did that earlier today, if you take 3, 4, 5 samples from the bottom, basically the only thing you have is quagga and tiger shrimp. And that's actually quite sad, because like the biodiversity that this system had before gets less and less, because the other species are becoming less and less because they don't have any space to grow. They like have a lot more competition for food, for space, like I said. So the biodiversity is actually becoming less, even if you have more mussels and the biomass is going up because you have more species. Biodiversity is going down, and that's actually quite a sad thing. But at this stage, there's not really a lot you can do, because the species is all over the lake. It's very successful, and how do you get something that is so successful out again? So these, like the quagga mussel, and the tiger shrimp, these are 2 very, very important successful invasive species of Lake Constance. And the quagga mussel is actually like getting the whole like economy around the groundwater and the drinking water here at Lake Constance really into trouble, because maybe you know that. So from Lake Constance, a lot of water is taking to supply millions of people with like fresh water to drink. So there are like huge pumps where the water is sucked out of the lake and then transported all over the country, not all over the country, but all the way to Stuttgart, for example. And the quagga mussel is growing like in these pipes and are blocking the filters, blocking the pipes, and they had to, I think they had to employ 4 or 5 more people just to clean the whole like tube system for the drinking water from quagga mussels, and this is just gonna get worse. So it's just not having like impacts on biodiversity, but also on local economy here. So before we go down to the microscope, I just clean up here a bit, hand over to Frank for a second, and then I'll meet you down at the microscope.
Yeah, this is Frank again. And I want to tell you how this boat was coming to Lake Constance, because for sure we could navigate in really shallow water areas. We have been in different places, like in Prague, like in Paris, on the rivers. But there is no way to come on the river to Lake Constance, because there are the waterfalls in Schaffhausen. So we have been already with the boat directly from Hamburg to Basel, but not further. So we had to use a truck to bring the boat here to the Lake Constance, and the boat has a size of 14 meters in the length and 4.5 meter wide, and this is the maximum you can transport on a normal truck on the roads. So this is the trick. We bring Aldebaran here to Lake Constance. Okay, that's it here from the deck, and we will go down now to the saloon, and Valeska prepared the microscope and prepared the probes we took earlier, and let's see the fascinating images of the plankton now.
Microscope is like taking quite some time and some effort, because it's very accurate kind of science, and these like whole setup is very sensitive, and the organisms that we want to look at are super small. So this is kind of the plankton that we caught earlier. Just gave them, like I said, I just put them into the fridge to keep them happy. And now we just take like a bit of water out. Just see that I get different species here for you. Let's see. Okay, so here's something. Let's start with this. Let's see what it is. So you always use a microscope to look at plankton. So just put that under the microscope, and then we should have some kind of image here soon, I hope. Okay, let's get some light. So I will have to look like through the microscope here, and then see if I can get like a picture for you on the screen that is like big and sharp enough. So just give me a second. Like I said, like working with the microscope is not fast. Takes a second. Okay, I found something, and now I'll try to like make it sharp for you. What? I need to see the screen, please, so I can see what you see. Aha! Look at this. So here's something. Just let it move a bit to. Oops. So, okay. Yes, very nice. So this is a very big guy. So I'm on the like the biggest resolution here on my lenses, and it still don't fit completely into my picture. But this is one of the two most important species when we look at zooplankton in Lake Constance. So this is a water flea. So they're quite big guys actually for plankton. And you can see here, like the big dark spot that you can see is its eye. And then I just scroll down a bit. You can see this green channel. And because zooplankton is feeding on phytoplankton are algae are green, you might like already can guess what that green thingy is. Yeah, it's the digestion system. So water fleas are like filtrating phytoplankton, so they're using their antenna to just like filter the plankton into their digestive system, and then the algae are going zoop all the way down, and then they, let's say they exit the water flea down here. So this is why it's all green. And yeah, like I said, water fleas are one of the two most important species when we look at zooplankton here. There are two different species of water fleas. This one is Daphnia longispina, it's called. So you can see that the head is actually quite flat, and it looks a bit like it's wearing a helmet. So it's kind of like a, I don't know, like a Darth Vader helmet that it has on. And this is the water flea that is not very well protected. There's another one, and we can just like make our way through if we can find that. Because plankton is just, just swimming through the water column, and they're teeny tiny, so they're basically they get eaten by everyone. So everybody is just going onto the poor micro. Oh, here we're seeing a full one. So this is also a water flea, but a smaller one. So we can see the whole animal, and you can see actually its heart bumping. So right now it's super stressed and very, very excited because it's out of the water and it's laying like under light and just getting looked at it by us. So it's probably a bit pissed, but we'll just make it short for it. So here you can also very nicely see the antennae that they're using to move in the water. And plankton is called plankton because they are not moving really actively through the water, but are drifted by currents. So they're not strong and big enough to work their way through currents, but they're completely dependent on the water movements. So everything that is moving actively, like we do in water or fish would do, are called nekton, and all the stuff that just drifted away by currents is called plankton. And so what these guys do to avoid being eaten by predators is that they move vertical in the water column. So at night, they're at the surface feeding because all the predators are, they're not really asleep, but just like put it that way to make it a bit simpler. So they're not hunting, so they're going up, feeding, and then when it gets light and all the predators and everything that is going to eat them is coming back, they're moving down in the water column vertically below the euphotic zone that we just learned. So below 15 meters depth, where it's dark, where no one will eat them. And as these guys are only like 3-4 millimeters big, and they're traveling 15 meters up and down every day, this is actually the biggest migration in the whole animal kingdom, which is quite cool, I think, at least. But I'm also a biologist, so sometimes I'm a bit nerdy, right? So let's see if we can find on this one the other important species of zooplankton that I wanted to show you, but I think on this one it's just water. Ooh, look at this. This is also water flea, so it's not the other species that I wanted to show you, but this is a female and it carries eggs. So this water flea is actually, let's say it's pregnant. So this is a female and it's carrying eggs here. Super cool. Nice. I love plankton. And I hope I can like get you a bit excited about plankton right now. So this guy's not looking very good anymore. Here's one more, but I think it's also, yeah, it's a flat. So they all have flat heads. So I'm just trying another sample for you to see if we can find the other species that I want to show you. Because there's another species of water flea. And I will just tell you, to save some time right now, they don't have this flat head. They have actually a very, they have kind of spines on their head and on their back. So they look a bit like a toothpick, really. So very sharp. And this is because they don't want to get eaten. And if you ever try to swallow a toothpick, I mean, you know why you wouldn't do that, right? Because it's just very hard to swallow. So they are using their body form to avoid predation, which is very smart when you don't have the possibility to really protect yourself. And this is also, so this is the other species of water flea. So I just have another sample here, so we can just try again. But that's also like a thing with plankton. You, like I said, you never know what you get. It's wet now. Okay. Whoop. Okay. I will just scroll through this again and see what we got in here. Yeah, and we're lucky. Here we go. This is just what I was talking about. So this is the water flea again, and you can see it looks very similar. So you also see the green digestion tract, you see the antenna and the black eye, but it does not have this helmet, but it has this spine, and this is normally much longer, and it has this spine on this back. So in total you have kind of this toothpick coming out of the water flea on both sides to avoid predation. And this is the other species, that's called Daphnia cuculata. So remember the other one was Longispina, so this is cuculata. And this one has this wizard hat, so it doesn't have like a Darth Vader helmet, it more has like a Dumbledore hat, but they're both water fleas. And then I just scroll through here a little bit more to see if we can find the other species of zooplankton that I want to show you. That's all water fleas. So it seems like our plankton probe was very, very water flea rich, but I actually want to show you some copepods. If we cannot find copepods in here, I made a nice little drawing that I'm going to show you. That's also okay, but of course I would like to show you one in here. But I don't think that we're lucky. Once again. Yeah, but that's science, guys. You have to be a bit patient. Sorry to tell you, and I know that's sometimes it's super annoying and frustrating, but this is how it is. Don't want to lie to you. If you're thinking about studying biology as I did. Ooh, this guy is squeezed. Sorry, just going away. Okay, so I cannot find a copepod here, but maybe I can just show you. Let me think. Yeah, I'll just show you my drawing, maybe. Because I don't think that we can keep talking forever. So this is basically a copepod. So it just looks exactly, so if you all have seen SpongeBob, right? Don't lie to me. You all did, right? So there's like a plankton that is always super grumpy. It's always like walking around like this. And this is a copepod. So it's just like this very round body, and then it has like on its head, it has this big antenna, and it's moving through the water column with its antenna. And this is the other very important species of zooplankton that we have in Lake Constance. And they're not filtering phytoplankton, but they're actively hunting. So they have a very big eye, and they can actually see stuff. So they're really hunting for other plankton, which is quite cool. And I think that I might have another, let me just check the time. Do we still have time? How many? 15. So maybe we can just like go through I'll just look for my slide. Oh wait, I think I've drawn it somewhere else. Just this mouse. Because there's like with the phytoplankton that is actively hunting, so the copepods, there's actually something quite nice that I can show you. Where's the... Here. Just do that. Big one. So if you look at plankton communities, so if you take a plankton net and then go out and look at the plankton community in a lake over time, the thing that you find is that as soon as like spring starts and as soon as the sun is coming out, phytoplankton, so you can see that here in green, is starting to grow. So they immediately are species of phytoplankton that are growing very, very, very fast, and they're going up. So they're producing a lot of biomass in a very short amount of time. And in like March, April, they're already like blooming, let's say. And then shortly afterwards, the zooplankton that is feeding on the phytoplankton, just a bit later, you can see that here in blue, is also going up because they need the phytoplankton to feed on. So they're waiting for the phytoplankton to bloom and to grow, and then they start feeding on them, and they're also, like, their numbers are going up as well. And then there's this point where the phytoplankton cannot grow anymore because they have used all the nutrients in the water, and the nutrients are basically empty, so their biomass is going down again. And there's this phase where there's a lot of zooplankton in the water and very, very few phytoplankton, which means that the water is very, very clear, and that is normally right now. And this is called clear water phase. And very, like, logical now, the phytoplankton is going down, so the zooplankton is also going down because they don't have anything to feed on anymore, so they cannot grow any longer. And then also in Lake Constance and most other aquatic systems, we have a second peak of phytoplankton because there are some species that are very simple and they have a super fast growth, that are the ones that are already at their top in March, April. And then when they are kind of done, when their phase is over, we have other phytoplankton that are a lot more complex. Their structures take way more time to build, so they have maybe calcium carbonate skeletons to avoid being eaten, or they are much, much bigger and form huge colonies with other phytoplankton, and they take just a little bit more time to grow, and they have their phase then late in summer, and this is why we see that second peak. The phytoplankton is kind of following again, but this peak is also much lower than the first one, but they're also following again, feeding on that more complex phytoplankton, and you can also imagine that you need other species of zooplankton, because if you have an algae that has a super hard surface and like protects itself very, very well, you also need a zooplankton that is able to break through that surface and to be able to digest that algae. So also the community here changes a bit. And this is like a typical predation curve. So eaten, like eat and being eaten, right? So this curve would also work exactly more or less for something like rabbits or hares, and then foxes or wolves. So, you know, the prey is going up and the predators are following, and when the prey is going down, the predators are following as well because food is limited. So this is something you can like see very nicely on the phyto and zooplankton communities in lakes, like here. So yeah, I think that's very interesting. And plankton, I know, is super tiny, and it's like maybe hard to get excited about it because it's not just, you know, as big and cool as fish and whales maybe are. But very important is that plankton is really the very, very basis of all food chains in aquatic systems. So it doesn't matter if it's like big oceans or if it's small lakes. If there's no phytoplankton and if there's no zooplankton feeding on the phytoplankton, then there's no crabs, there's no fish, there's like nothing else that is that is able to grow, because the base of the food chain cannot be left out. Like if the base is not there, there's nothing. So they might be teeny tiny, and it might get a while to like see and accept their beauty, but they're the base of all food chains in lakes, rivers, and oceans. Yeah, and I think that was kind of the plankton part that I wanted to do with you. And yeah, I don't know if there were like questions coming up, maybe that we could answer, or no, if there's anything else that Frank want to tell about the boat or the projects.
Yeah, I can. We have to. Yeah. Sorry, I have to take another microphone. Everything a bit tricky on a boat, and maybe I like to tell you a little bit about the projects here with Aldebaran. I already mentioned that we have been in the Caribbean recently, in the Mediterranean, and on some rivers. And after this trip here in Lake Constance, we go to Dresden. And from Dresden we make a big trip on the river Elbe, from Dresden to Cuxhaven to the North Sea. And during this trip we make some samples for plastic. We make a campaign for outreach for plastics in rivers and plastics in environment in general. And this will be done with our colleague Carla. So if you're interested in the school to join this trip, you're really welcome. We will try to make live broadcasts from the trip as well, and then you can see hands-on with scientists, and you can see the beautiful landscape of the river Elbe. And after river Elbe we go to the North Sea, and there we make a project since more than 15 years. This is the young students contest for marine research, and we will have 3 nice projects about sound in the ocean. So, you know, when there is too much sound in the ocean, it hurts the whales and the dolphins. They lose the navigation and things like this. And we have 3 nice projects from schools all over Germany. And after this, we will go to Berlin with this boat, because there is the Day of Open Door of the German Parliament, and we will also be part of this. So if you want to join the Meereswettbewerb, which is the national contest for young people, or if you want to join us as a volunteer someday, you're really welcome. And I think this was it from our today broadcast here from Aldebaran. And now we make a small talk in Teams with Valeska, and I'm very happy to make this broadcast for you today, and I hope that it will work, because it's a really big challenge to transmit from a boat. We have no cable connected to any internet, everything is going wireless, and so hope you enjoy it, and hope you enjoy now Valeska's question and answers.